We are going to use Hess's law to calculate delta H for the reaction dinitrogen monoxide N2O plus nitrogen dioxide NO2 goes to 3 nitrogen monoxides NO. Up above it, we have delta H's or heats of reaction for 3 other reactions. With Hess's law, we can try to manipulate the reactions for which we know the delta H to add together to give us the overall reaction that we're trying to determine. If we can do that, we can similarly manipulate and add together the heats of reaction to get the heats of reaction. So I'm going to start by looking at the above 3 reactions. I'm going to call the top one number 1, the second one number 2, and the third one number 3. And I'm going to see if I can manipulate any of those reactions to give me this N2O or dinitrogen monoxide in the reactant. And if I look down through the 3, I see that the last one has 2 N2O on the reactant side. So I'm going to take that reaction number 3 and I'm going to divide it by 2 all the way through. So that will give me N2O goes to N2 plus 1/2 O2. I took reaction 3, the bottom of the 3 reactions there, and I divided each coefficient through by 2. Next, I'm going to look at my second reaction, or a second reactant that I want, and that is the NO2, nitrogen dioxide. If I look up at the 3 reactions that I'm given, I see that one of them has NO2 in it, but it is on the product side, 2NO2. So I can start by perhaps reversing that reaction. So if I take number 2 and reverse it, I get 2NO2 goes to 2NO plus O2. Okay? But I have a problem here now, and that is eventually I'm going to want to add these reactions together to give me my overall reaction. But if I do that right now on the reactant side, if I add these, I have an N2O and a 2NO2. But if I look at the reaction I'm trying to determine, I only want an N2O plus 1 NO2. So I'm going to have to do some further manipulations. So I'm just going to erase this right now. And if I also divide this by 2, I can get the product that I want. So I'm just going to divide all these coefficients by 2 now. That'll get rid of that. That'll get rid of that. And that's going to make this one a 1/2 O2. Okay. So now I look like I'm in good shape on my reactant side. But on my product side, I still have some problems. So let's take a moment and look at what we need and maybe what we have that we don't want. So if I look at this, I have what I want on the reactant side. I have a N2 on the product side now that I really do not want. I have an NO, which I do want on the product side. and I have some O2s that I do not want on the product side. So what we would like is to perhaps be able to cancel these three. If we look up at our other reaction, reaction 1, it has an N2 and O2 on the reactant side. So let's start with that. N2 plus O2 on the reactant side. That's looking promising because now it looks like we'll be able to cancel this NO2 that we want and cancel the O2. So I'm going to finish writing that first reaction. Reaction number 1 is N2 plus O2 goes to 2NO. Now, if I want to add all these together, I should be able to cancel my N2s. I have a half O2 and another half O2 that I can cancel with the O2. And look, I have what I want on my product side now. NO plus 2NO gives me 3NO, or nitrogen monoxide. And on the reactant side, I have my N2O plus my NO2. Okay? So now it looks like I've been able to manipulate those three reactions in a way that will add together to give the reaction that I wanted. And I generally make sure the reactions add up before I manipulate the delta H's, but you can certainly manipulate the delta H's if you want. So now let's look at our delta H's. For reaction 3, the delta H was negative 163.2. kilojoules. But I divided it by 2. That means we also have to divide that by 2. Next, I have a reverse and divide number 2. So my second delta H is negative 113.1 kilojoules, but I reversed it, which will change the sign to positive, and I divided it by 2, so I have to divide that by 2. Finally, the last reaction, my reaction number 1, has a delta H of 180.7. And so I can leave that one as is, the 180.7. Adding all three of these together, I get 155.7 kilojoules, which will be my delta H for my overall reaction.